Hello students, so today we are going to discuss about magnets. Magnets. I'm sure you all must have played with this fascinating object in your childhood and enjoyed while playing with them. Now have you ever seen things that have magnets attached to them? Well, if you observe things around you, then you can say that there's magnet present almost everywhere. Well, surprised? Okay. So then let us explore certain things around you one by one and see where all magnets are present. So have you seen these stickers that remain attached to the doors of the almirahs or the refrigerators? What do you think? Why do these stickers, they get attached to such surfaces? Or if I have to talk about this pencil box. So where can you see that the lid, it fits tightly when we close it, even without a locking arrangement. So what do you think? Is there something that is helping it to close firmly? Or in case of many of these purses, or for that matter, even the handbags, you will find a system that helps them to close easily and tightly. So students, in all the above examples or the objects such as your sticker or be it your handbags or your purses, you have magnets fitted inside them. You want to see where these magnets are present? Well, in case of the stickers, the magnet is present on the beneath surface, while in case of the pencil box, it is present either on the inner side of the top lid or the bottom of the box. And many of you would be surprised to know that magnets are used in refrigerators to keep their doors closed tightly. Now, magnets are also used in the cabinets of your kitchens or your bathrooms to keep them closed. So there are some of your day-to-day things where you can see the importance of magnets. But then these magnets, they are also used in vacuum cleaners, laptops, speakers, and many more things. And that's why I said you can find magnets almost everywhere. Now, till now, we've learned about the uses of magnets in various things. But aren't you excited to know more about this fascinating object? Well, for this, let us do an activity by using this magnet. So here is a bar magnet which is placed on the table, and now I just sprinkled some of the iron filings over it. And I'm going to sprinkle some more iron filings over this. Okay, so now what do you observe here? Well, you can see that these iron filings, they stick to the magnet. Now just observe this magnet very carefully. And here's an interesting question coming up for you now. So do all parts of the magnet, they attract these pieces of iron filings equally? Or do you find anything peculiar here regarding the way the iron filings, they stick to this bar magnet? Now just to make things a little bit more clear, I just pick up this magnet. So now clearly you can see that these iron filings, they are more crowded towards the regions which are close to the two ends of the bar magnet. Okay, so now let's have one more experimental proof regarding this observation. And this time I'm going to repeat the same activity, but then this time I'm going to take a different shape of a magnet, such as a U-shaped magnet. And now I place this U-shaped magnet on the table, and once again I start sprinkling some iron filings around it. So what do you see here? Once again, as I keep sprinkling the iron filings all around this U-shaped magnet, so these iron filings, they again start sticking to the magnet. Okay, so here I go with the final round of sprinkling the iron filings. Okay, so there you see, again the iron filings, they have stuck to this U-shaped magnet, and if I lift this up, again you can see that these iron filings, they are more crowded towards the poles of the magnet. So you see, they are more crowded towards this poles of this magnet. Okay, so we'll have another view of it just to make things more clear. You see, they're more crowded towards the ends of the magnet. So now why do you think? Why is it so? Why these iron filings, they're more crowded towards the ends of the magnet and not towards the center of it? And that's precisely because the magnetic strength, it is strongest at the two ends of the magnet and it is weakest at the center. And that's the reason why iron filings, they're more crowded towards the ends of this magnet and less crowded towards the center of this magnet. Similar was the case with the bar magnet as well. You see here, more crowded towards the ends of the magnet and very less crowded towards the center of the magnet. So you can see both the views. Okay. So before we proceed further, let us have some fun with this magnet. And the activity which I am going to do now, it is called the dancing iron filings. So to carry out this activity, I take a glass sheet and place it on a certain height. And on this glass sheet, I place a sheet of paper. And we've put some iron filings on this paper. Now, I hold this magnet beneath this glass sheet and I'll move it in a circular motion. So what do you see here? Yes, you can see that these iron filings, they also move in circular direction. That is, in the direction in which I move this magnet. And the iron filings, they move in the same direction as the motion of the magnet due to the attractive property of the magnets. And it seems that these iron filings, they're just like dancing. And that's why this activity is known as dancing iron filings. So wasn't it fabulous and an interesting thing to do? Okay, so let's come back to our topic now. So till now, what have we studied regarding the magnets? Yes, we have studied that the strength of a magnet, it is weakest at the center while it is strongest at the ends of the magnet. So now don't you think that some special name should be given to such regions where the strength of the magnet is strongest? Well, these regions, they are known as the poles of the magnet. Now, when I use the word poles, we have also heard that our Earth, it has two poles. So what do you think? Is there some relationship between the poles of the magnet that we've been discussing and the poles of the Earth? Well, to your surprise, Earth itself is one of the biggest occurring natural magnets with two poles, the North Pole and the South Pole. So till now, I presume that you've got some brief idea regarding the magnets. But have you ever wondered how magnets were discovered? Do you wish to know how magnets were discovered or who discovered them? Well, there's an interesting story behind their discovery. Now, there was a shepherd named Magnus who used to take his herd of sheep and goats to the nearby mountains for grazing. And to control his herd, he used a wooden stick, which had a small piece of iron attached to one of its ends. So one day, while he was doing his work, he found that it was hard to pull the free stick from a rock. And it seemed that as if the stick was stuck to the rock. And later on, he came to know that the rock was a natural magnet. And it attracted the iron tip of his wooden stick. And this is how natural magnets were discovered. And such rocks were given the name of magnetite. And that's perhaps after the name of that shepherd. And this magnetite rock, it is a very rich source of iron. Now, some people believe that magnetite was discovered at a place called Magnesia. So in this way, it was discovered that certain rocks have the property of attracting the pieces of iron. And these rocks are considered as naturally occurring magnets. Now, the rock such as the lodestone is a type of magnetite. And it was one of the earliest natural magnets to be discovered. Now, this lodestone, it is nothing but an ore of iron, which attracts the pieces of iron towards it. And after years of study, we now know that these lodestones, they also attract other materials such as the cobalt and the nickel. And gradually people also discovered the process by which the magnets can be made from iron. And these man-made magnets, they are known as artificial magnets. Now, artificial magnets can be prepared in different shapes. For example, we can have a bar magnet. We can also have U-shaped magnet, which is in the shape of a U-shaped. And then we can also have ring-shaped magnets. You can see it is in the form of a ring. And then we can also have cylindrical magnets. And then how about the arc-shaped magnets? So it is in the form of an arc. You see this arc over there? Yes, so we can even prepare or we can even make arc-shaped magnets. And now I'm going to introduce to you another surprising magnet. And that is flexible magnet. Have you ever heard about this flexible magnet? So yes, even magnets can be flexible. So this is all about magnets in general. And in the next module, we are going to talk about the magnetic and non-magnetic substances.